Welcome to SISYA Class. This is your Master Physics teacher Nadeem Hafeez. My name is Nadeem Hafeez and I'm your, as I said, Physics Master Teacher. I have done BTech in Civil Engineering and I have over 5+ years of experience in teaching students and guiding students. Okay, so without any further delay, let's start the class. We are going to study about the topic equivalent resistance, and this is for class 10 students. This topic is in your chapter electricity. Okay, now this is very important topic. Why? Because there are numericals asked in the class 10th board examinations from this very part. Okay, now at the first you will say that what do I mean by equivalent resistance? Yeah, so it's very simple. If I have two resistors, three resistors, four resistors, okay, I can connect them into different combinations. Yeah, what will be their net effect when I combine them? That's what we study in the equivalent resistance. I hope that is clear to you. So before starting the class, so first, the way of combining the resistors is the series combination. Okay, what do I mean by the series combination? It is very, very simple. When you connect the resistors, okay, end to end, okay, when you connect the resistors end to end, that's what it means, that the resistors are connected in series. Okay, end to end connection is there. Now here I have put actually how the resistors look like. Okay, but when you are drawing the diagrams, you just make their symbol like this. This is the symbol. Yeah, so this is one, then there is the second one like this. Yeah, then there is the third one like this. Okay, let's suppose the resistance of this is R1, resistance of this is R2, resistance of this is R3. It can be 4, 5, 6. Okay, similarly it can extend up to n number. Okay, so let me name this as, let's say the resistance is Rn here. Okay, so what will be their net resistance when I connect them like this? It will be very simple. The equivalent resistance will be equal to R1 plus R2 plus R3 plus so many resistors which will be there plus Rn. I hope this is clear. So you just have to sum all the resistances, that will give you the equivalent resistance when they are connected in the series. Okay, I'm not going into the depth of this, like I'm not solving it, I'm not proving it. That's proven using the Ohm's law. Okay, but I'm just telling you this such that we can solve the questions. Okay, so now resistance in parallel. Now what do they mean? Like the resistors are connected in the parallel. As you can see, they are not connected end to end. Okay, they are not connected end to end. They are connected like this. Now if I draw them on the diagram, okay, if I draw them on the paper, so they will be like this. This would be R1, yeah, then this would be R2, clear, and then this would be R3. Okay, let me name them like this. Okay, and there will be some supply. Okay, we are not concerned with the supply right now. Okay, battery, cells. Okay, so R1, R2, R3. Similarly, there can be n number of resistors connected like this. Okay, let me name the nth resistor like Rn. Okay, so now what will be the equivalent resistance? What will be the net resistance when they are connected like this? Yeah, so it will be equal to 1 divided by R equivalent equals to, then we are taking the reciprocal. Okay, 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Similarly, how many resistors will be there? That will be added, 1 divided by Rn. Okay, please don't make any mistake here, because some students, I have seen some students, they just take the reciprocal and they say that it is the same thing, that R equivalent equals to R1 plus R2. It is not. Okay, you need to take the reciprocal of these. Got it? Very good. So let us see some questions. We will start with the very basic questions and then we will see some mixed problems here. So our first question is, three resistors, 2 ohms, 3 ohms and 5 ohm resistance, okay, are connected in the series. Obviously, series connection is end-to-end connection like this. Okay. Find the equivalent resistance of the circuit. Okay, they are connecting the circuit like this. I'm not showing you the whole circuit, I'm just showing you the resistance, how they are connected. So they are connected in the series, and when they are connected in the series, what will be their equivalent resistance? Yes, it is very simple. We have studied this, yeah, that if there are three resistors, their equivalent resistance will be R1 plus R2 plus R3. Got it? That's nice. What is R1 equal to? It is equal to 2 ohms. What is R2 equal to? 3 ohms. And R3? 5 ohms. That's nice. So 2 plus 3 is 5. 5 plus 5 is 10. So what will be the net resistance here? What will be the equivalent resistance here? It is very simple. It will be 10 ohms. Okay. See, I started with the most basic question. Okay. Such that when I go to the mixed problems, you'll be able to understand that very easily. Okay. Let's see this. Three resistors, 3 ohms, 2 ohms, and 18 ohms. Okay. They are connected in the parallel like this, as you can see. What is the equivalent resistance? Okay, so instead of these three resistances, I will only put one. But what will be the resistance of that? I need to calculate it. So they are in parallel. I can clearly see 1 divided by R equivalent is the formula, equals to 1 by R1 plus 1 divided by R2 plus 1 divided by R3. Got it? Yeah. So 1 by R equivalent will be equal to 1 divided by, what is the resistance of first? It is 3. So I'll write 3 here, plus 1 divided by second, it is 2, plus third, it is 18 ohms. Got it? Yeah. So 1 by R equivalent will be equal to, I will take the reciprocal of these three. Sorry, the LCM of these three. 3, 2 and 18. Yeah. 3, 2 and 18, their LCM will be 18. Okay. You can calculate it. You have studied that, yeah. 2, 3 and 18 LCM. It will come out to be 18 only. So 18 divided by 3 comes out to be 6. So here we write 6 plus, then here comes 9 plus 1. Now these things you study in the maths. Okay. 1 divided by R equivalent will be equal to 9 plus 1 is 10 and 10 plus 6 is 16 divided by 18 ohms. Yeah. But is this the thing we are looking for? No. We are searching for the equivalent resistance. Here it is 1 divided by R equivalent. So I need to take the reciprocal. Yeah. So reciprocal, taking the reciprocal, R equivalent comes out to be 18 divided by 16 ohms. Got it? Yeah. Okay. 18 divided by 16 ohms. Now you can simplify it. Yeah. You can simplify it. There is nothing wrong with that. Use this. Yeah. Okay, so you see, after simplifying 2 8 are 16, 2 9, 18. So it comes out to be 9 divided by 8 ohms. Okay, so 9 divided by 8, 9 by 8 ohms is the equivalent resistance of these three resistances. Okay, good. Shall we move to the next question? Let us see. There we go. There is a combination of series and parallel. Okay, what it says. A 2 ohm resistor is connected in series with two 6 ohm resistors. Okay, so that means this 6 ohm resistance, this 6 ohm resistance, they are connected in the parallel. Okay, after that, this 2 ohm resistance is connected in the series with them. Yeah, what will be the net equivalent resistance? Let us see. Okay, first of all, let us solve these two because they are connected in the parallel. So 1 divided by R equivalent equals to 1 divided by R1 plus 1 divided by R2. Do we write 1 divided by R3 here? No, because there are only two resistors which are connected in the parallel. Okay, solve it. 1 R equivalent equals to 1 divided by R1 is 6. Yes, R2 is also 6. Okay, so it will be equal to 1 by R equivalent equals to, the LCM comes out to be 6 only. Okay, and on top it's 1 plus 1, so it will be 2 divided by 6. Simplifying it, 2 1 2 2 3 6. So when you take the reciprocal of this, you see you take the reciprocal. So R equivalent will be equal to 3 ohms. Got it? Yeah. R equivalent will be equal to 3 ohms. Now that 3 ohm resistance will be in series with this 2 ohm resistance. Let me write it like this. See, this is the 2 ohm resistance which is there. And instead of these 2 ohm, these two 6 ohm resistors, I can make only one resistor of 3 ohms like this. Okay. So when we sum them, 2 plus 3 is 5. Okay, simply. So net resistance or net equivalent resistance will be equal to this 2 ohm resistance plus this 3 ohm resistance because they are connected in series now. Okay, so 3 plus 2 is 5 ohm. Did you get it? Yeah. If you are sure, then let us move to the next. Yeah. Okay. So no statement is given now. Okay. Now you just need to figure out which is connected in series, which is connected in parallel. Let me solve this one for you. Okay. Let's solve it together. First of all, you can see that these three resistors, they are connected in the parallel. Tell me yes or no. Yes, sir, they are connected in the parallel. Then these two ohm resistances, they are also connected in the parallel. So first of all, let us solve them. Okay. So I'm solving this now. 1 divided by R equals to 1 divided by R1. What is R1? It is 3 ohms. Plus 1 divided by R2. What is R2? It's 3 ohms again. Plus R3. It is 3 ohms again. Got it? Okay. So 1 divided by R equals to, we take the LCM of these three. So it's taken like this. It will be 3 only because 3, 3, 3. LCM is 3. Okay. And on top it comes 1 plus 1 plus 1. Okay. 1 plus 1 plus 1 is 3 divided by 3. Okay. So now you take the reciprocal. So R will be equal to 1 ohms. So instead of these three, okay, I can put only one resistance of 1 ohm. That's it. Okay. Now come to this. Now I'm solving this. Now here 1 by R equals to 1 by R1. What is R1? It is 2 ohms plus 1 by R2. It is 2 ohms also. Okay. Do we write 3? No. Obviously it's not here. Third resistor is not here. 1 by R equals to LCM of these two comes out to be 2 and on top it comes 1 plus 1. Okay. So it is 2 divided by 2. 2, 1, 2, 1. Yeah. So now take the reciprocal. R comes out to be equal to 1 ohms again. Okay. So instead of these two 2 ohm resistances, I can put only one. Okay. Which has the resistance of 1 ohms. So the circuit simplifies like this. So instead of these three, I'll put only one of 1 ohm resistance. Then there is the 5 ohm resistance connected. Yes. This, okay, this over here, it's connected in the series. And then instead of these two, I can connect only one resistance of 1 ohm. Okay. Now, what will be the equivalent resistance here? They are connected in the series now. You see 1, 5 and 1. So I'll apply the series formula. R equivalent equals to 1 ohm plus 5 ohm plus 1 ohm. What is that equal to? Yes, 5 plus 1, 6, 6 plus 1, 7 ohms. Yeah. So the net resistance between the point, let me name this as A and let me name this point as B. So the net resistance between the point A and point B is 7 ohms. I hope you understood this clearly. Now, after this, you can solve more and more questions on this. Okay. And you will see, there won't be any question which you won't be able to solve. Okay. I hope you enjoyed the class. Thank you for joining.